Let's see the main postulates of this Planck's quantum theory. Each radiation, as per Planck's quantum theory, the main postulates are each radiation, that means each electromagnetic radiation or light, is associated with each radiation is associated with a certain amount of energy, called radiant energy. Each radiation, any radiation, is associated with certain amount of energy called radiant energy. Next, these radiations, any radiation, is absorbed or emitted in the form of small energy packets, not as continuous manner. These are absorbed in small fractions. So radiations are, propagation of radiations are discontinuous. Propagation of radiations or propagation of radiation is discontinuous. That means radiations are not emitted in a continuous manner as parts. In first second, some part of electromagnetic radiation will be released. In another second, in the next second, another part is released. In the third second, in that way, for each second or each certain fraction of time, what happens? Electromagnetic radiations are released as parts, not in continuous manner. So propagation of radiation is discontinuous. Third one, each radiation is associated with some energy called radiant energy. This radiation either absorbed or emitted by a body as a small energy packets. Radiation is absorbed or emitted in the form of small energy packets. Small energy packets called quanta. Those small energy packets are called what? Quanta. Quanta is a plural number. Quantum is its singular number. Okay, singular word. Here, this is called quanta. It is called, this quanta are called photons in the case of light. In the case of light, these quanta are called photons. These quanta are called photons in the case of light. For radiation, we use the word quanta, quantum, quanta. Similarly, in the case of light, visible light, we use the word photons. So here, the energy associated with each quantum is directly proportional to the frequency of radiation. Energy associated with each quantum or photon is directly proportional to frequency of radiation. Frequency of radiation. Let E be the energy of each quantum. Energy of one quantum, one energy packet of radiation. It is directly proportional to nu. What is nu? It is the frequency of radiation. E is the energy in one quantum or photon. Nu is frequency of that radiation. If we expand this, you will get a formula E equals to h nu, where h is Planck's constant. It is Planck's quantum theory, na? That's why the constant obtained in this case is named as Planck's constant. So where h is Planck's constant, its value is, Planck's constant value is 6.626 into 10 power minus 34 joule second. Or in ergs, its value is 6.626 into 10 power minus 27 erg second. So for energy, SI units are joules, CGS units are ergs. So in that way, it is the value, Planck's constant value in SI units or MKS units, it is the value in CGS units. Okay, so this is h value, Planck's constant value it is. So here energy associated with each quantum or photon is directly proportional to frequency of radiation. Next, another point is, these radiations are propagated in the form of waves. The radiations are propagated in the form of waves. But when they interact with matter, they behave like particles. These radiations behave like particles when interact with the matter. But when they propagate, they act as waves. Next, the energy in quantum is directly proportional to nu. So it is always, the energy in a quantum is always an integral multiple of h nu. Energy of quantum is an integral multiple of h nu. That means E equals to some integer n into h nu. So photon may have 1 h nu energy where n is n value 1, 2, 3 and so on. It's a simple number. So energy in a quantum may be 1 h nu, 2 h nu, 100 h nu or some 1000 h nu. But the h nu is not a fractional value. It is always a whole number. That means energy must be some 1 h nu, 2 h nu, 3 h nu like that. Not a 0.5 h nu, 0.7 h nu, 1.35 h nu, not like that. Those are all fractional values. Here n value is always a whole number. So these are the postulates in Planck's quantum theory. So see once again the postulates in this theory. First one, radiations consist of some energy, certain amount of energy. Each radiation has certain amount of energy that is called radiant energy. These radiations are propagated in discontinuous manner, not a continuous manner, discontinuous manner like that, as parts. Okay, each part of this radiation is called one quantum. This is one quantum, second quantum, third quantum, like that. So any object, this is an object or substance, it absorbs or it emits radiations in the discontinuous manner. It absorbs this side, from this side it is absorbing, from that side it is releasing. So radiation, whether it is absorbed or released, it is in discontinuous manner and in the form of small packets. These small packets of radiations, radiant energy, are called quanta. We use another word, photons. Okay, so different photons or quanta. So these are absorbed or released. Each quantum has, in each quantum, energy present is directly proportional to frequency, that means equal to h nu. So this is the energy associated with quantum, that may be 1 h nu, 2 h nu or 100 h nu. Okay, so these are the postulates in Planck's quantum theory.